Rational expressions. We are going to subtract two rational expressions with some god-awful denominators, and this one's going to be a doozy. So here we go. Here's your problem. You got 1 over x times x minus 5, and you're taking away 2 over x plus 1, x minus 5. Now, these factored denominators, no big deal, okay? No big deal. What we're going to do with them is we're going to, again, try to find a common denominator. We need a common denominator. So this is one of those cases where the common denominator should not be simply the product of the two denominators. Because think of it, if you multiply this quadratic by another quadratic, you're going to end up with a 4th degree with 4 factors in your denominator, and that's not going to be fun. Okay, especially in your numerator, it won't be fun either. So here's how we do this. All right, notice your first equation, your first expression has factors of x and x minus 5. All right, your second equation, your second expression has factors of x plus 1 and x minus 5. Notice x minus 5 is a common factor in both of them. That means you don't need to multiply x minus 5 twice. All you need to do is multiply the missing piece. So this first fraction, the only thing that it needs as far as to reach a common denominator is it needs to be multiplied by x plus 1. All right, so that's what I did with the first expression. I multiplied it by x plus 1 over x plus 1. The second expression, 2 over x plus 1 times x minus 5, simply needs the missing factor of x. So what I did to the second fraction is I multiplied it by x over x. Remember, multiplying by an expression over itself is equivalent to not doing anything because you're multiplying it by a value of 1. Okay, so that's the hard part. Figuring out the common denominator, that's the hard part. But take a look. Each fraction now should have a denominator of x times x minus 5 times x plus 1. Look at the second one. X times x minus 5 times x plus 1. Okay, and I'm simply going to simplify my numerator. So x plus 1 times 1 gives me x plus 1. And then x times 2 gives me 2x. And now I've got a common denominator, which I'm not going to bother to multiply that out to get a cubic unless I'm told to expand it. So what I'm going to do is I'm just going to combine my numerators now. So x plus 1 minus 2x. Well, your like terms are x. Subtract 2x, you get a negative x. So this is negative x plus 1. Let me show you that all of the steps were correct by showing you equivalent graphs. Equivalent expressions yield equivalent graphs. And I'm done. I'm done at this point. So again, the hardest part right here was finding that least common multiple, if you consider that to be a hard part. All right. You know, with numbers, we could compare this to, let's say I'm multiplying 2 over 2 times 3 times 4. All right, which is 24, 2 24ths. And I'm adding 3 over 4 times 7, all right? Well, if I wanted to find a common denominator, right? Well, this guy right here, I would simply have to multiply by 3 times 2, right? Or 3 times 2, okay? Because I've already got a common 4. And this guy over here, I'd simply have to multiply it by 7 over 7. And I know this could probably be simplified, but now I have a common denominator of 7 times 2 times 3 times 4. 7 times 2 times 3 times 4, right? So I really only use the missing pieces, the missing factors, so that all of it has the same denominator. That's really the big idea here. And there's not much else to it. Again, follow through with equivalent expressions yielding equivalent graphs, and you'll be on your way to success. So that is how you subtract two rational expressions with different denominators successfully. Okay.